our unit circles memorized, we can now solve a bunch of questions without our calculator, using what we know from our unit circle. So the way that you would tell if this was a unit circle question on a test or an exam is you'd be like, oh, it's on the non-calculator part. It probably involves my unit circle somehow. So how do we solve these questions that are now non-calculator that we've done in the past with our calculator? So reminder, if this question was in grade 11, first of all, instead of between 0 and 2 pi, it would have said between 0 degrees and 360 degrees. You would have gone to your calculator and found the reference angle by doing sine inverse of positive root 3 over 2. You would have looked at your CAS rule and said, since sine is negative, it has to be in quadrants 3 and 4. And once you had your reference angle, you would have been able to find out what that angle is in quadrant 3 and quadrant 4. Now that we have our pi plate, this process gets done very quickly because we don't need our calculator. First of all, you would say to yourself, is root 3 over 2 ever a y coordinate on my pi plate? Yes. If I look in quadrant 1, it's a y coordinate in my pi over 3 family. So that is how fast it is to find your reference angle. You just have to think in quadrant 1, when is my y coordinate? Root 3 over 2. That's my pi over 3 family. That's my reference angle. CAST rule works exactly the same as before. Sine is negative, so it can't be in quadrant 1 or quadrant 2. It has to be in quadrant 3 and quadrant 4. Then writing your answer, again, going to your pi plate, what's your pi over 3 family in quadrant 3? What's your pi over 3 family in quadrant 4? And we're done. So it's a lot quicker than what we had before, where we'd have to do all of the drawing of the triangles and figuring out our reference angle and doing pi plus our reference angle and 2 pi minus our reference angle. We can get that all quickly from our pi plate. So question number 2. Solve each question using exact values. Cos of theta is -1. Cos is your x coordinate. Think on your pi plate. Is your x coordinate ever -1? Yes. That's an axis family. So axis family ones, you can just write the answer. No need to even say a reference angle. That happens at pi. And this question is done. That's how fast you can do these now using our pi plate. Tan of theta. So now you think of your tan values. Do we have an angle where the tan is 1? Quadrant 1, that's your reference angle. Pi over 4. Now according to your CAST rule, tan is negative, so it can't be in quadrants 1 and 3. It has to be in quadrants 2 and 4. So what's your pi over 4 in quadrant 2? Maybe you use that strategy that the numerator is 1 less in quadrant 2. Quadrant 4, maybe use the strategy the numerator is double the bottom minus 1. If you get to a reciprocal function, the first thing you'll do is say, okay, cos is related to secant. So if secant of theta is 2, then cos of theta is 1 over 2. The angle doesn't change, the answer does. Your brain should be trying to figure out the reference angle before I write it down. So reference angle, when is your x coordinate 1/2? Pi over 3. And then according to your CAST rule, cosine is positive, so it can't be those ones. It has to be in quadrant 1 and quadrant 4. Pi over 3 in quadrant 1 is pi over 3, pi over 3 in quadrant 4, 5 pi over 3. Try the next one on your own. I'll put up the answer in a second. First of all, get the sine theta by itself, move the 1 over and divide by 2. And check how you did. So our reference angle is pi over 6. Then we need our pi over 6 family member in quadrant 3 and quadrant 4, 7 pi over 6, and 11 pi over 6. Next, we take everything you learned about quadratic equations from grade 11 and add trigonometry to them. So we're going to do a little review of grade 11 and see how that helps us solve it in grade 12. One of the big things you learned in quadratic equations in grade 11 was factoring. So in grade 11, this question wouldn't have cos. Grade 11 question would just look like this. What is x squared minus x equals 0? How would you solve it? And the biggest strategy you learned in grade 11 to solve quadratic equations was factoring, right? Sometimes it couldn't be factored. We'll get into quadratic formula questions as well in grade 12. But for the most part, we did things for factoring. Now, I don't know if you remember why you factor or the whole mathematical reasoning behind it, but I'm going to review that for you. And it's actually brilliant. And once you see it, you're like, oh, that makes so much sense. Okay? When something is not factored, it's very hard to guess and check what would work. I have something minus something. If right now I picked two numbers in my head and I subtracted them, and I asked you to only guess one, how long would it take you to guess? Okay, let me get two numbers in my head. Okay, I've got two numbers in my head, and I subtract them, and they're equal to 0. It's not this question, just I picked two numbers. You had to guess a number? Try. No, it's not 42. No. 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 Oh. How long would you have? It was 3.4. 3.4 minus 3.4. It would take you a very long time. We could probably, if I wanted to make this class painful, we could have just guessed for the next hour, and so, or next half an hour till class ended. And then, right? And then you could come back tomorrow, and I'd be like, keep guessing. And it would go on and on and on and on. Now, why do we factor? Well, factoring, in this case, there is an x in common. I can factor out the common x, leaving me with x minus 1. And the powerful thing about factoring, the beautiful thing about factoring, is it changed your question, which was subtracting. It changed it to multiplying. And this is why that's so powerful. I'm going to now pick two new numbers in my head. Okay? You just have to guess one of them. They multiply, and they equal 0. What's one of the numbers? 0. Got it on the first try. Does it make sense? If you're multiplying two things and it equals 0, one of them has to be 0. The other number was 17. I don't think you would have got that one. It would have been, I think I just like, we would have a party. If Max would have said 17.9, I'd just been like, it just like ruined the lesson, but that was amazing. But if two things are multiplied and they're equal to 0, one of them has to be 0. And that's what factoring does. It now lets us solve this because either this one is 0 or this one is 0. And so what we say in mathematics is we go, okay, if the green one is 0, well then x would be 0. That's easy to figure out. If the red one is 0, then x would have to be 1. And so factoring changes something from adding to subtracting to multiplying. And multiplying, if it's equal to 0, which is one of the key things in grade 11, your teacher would have said, oh, you're solving a quadratic equation. First thing we need to do is make one side equal to 0, was because of this. Now in grade 12, we have, instead of x squared, we have cos squared. We would recognize this as a quadratic equation where there's a common factor of cos theta in both the first and the second one. So we would factor out that cos theta, leaving me with cos theta here to make cos squared, minus 1 equals 0. And now that it's factored and the multiplication is right here, two things that multiply to equal 0, either this one is 0, in which case cos theta would have to equal 0, or this one is 0, in which case cos theta would have to equal 1. We're not done yet because we haven't solved for theta. In grade 11, you would be done because you solved for x. But now we have to go to our pi plane. Is the x coordinate ever 0? Yes, at pi over 2 and 3 pi over 2. Is your x coordinate ever equal to 1? Yes. It's equal to 1 right here, and on a lot of our pi plates, we wrote both 0 and 2 pi. But do I have to write them both here? Or should I just write 0? Or should I write them both? How do I know? And this is one place where you're often going to have to reread your original question and look at the domain. They told us to look for theta between 0 and 2 pi, and you see these equal signs? This means including 0 and including 2 pi. So if you just wrote 0 in this case, you would lose a half mark because you missed an answer. You would have to also include 2 pi. And the textbook, just to keep you on your toes, sometimes will ask this same question, and they'll write the domain like that. Subtle difference. Do you see the difference between the blue and the black? Just one little line. So if the question was written like this, and I included the 2 pi, then I'd lose a half mark for including an answer I shouldn't. So we, again, are really paying attention to those details, rereading our question at the end, because the details aren't actually that hard, but they just catch us when we're not paying attention. So rereading a question, looking at what the details are going to be really important. Second one, if you had a grade 11 question, or this technically could even have been a grade 9 question. It involves no factoring. How did you solve this in grade 9?
Bring over the 5 and then take the square root.
Bring over the 5 and take the square root. And what's the number one mistake that we make is we forget the plus or minus. So when you bring it over the other side, you have to do plus or minus. So when you have just a single thing squared, you can get that by itself and square root both sides. This is from the past. Now we have trigonometry. but I have a single thing squared, sine squared. I can get that by itself by moving the 3/4 over to the right-hand side. And then I can square root both sides. And just like before, I can't forget the plus or minus. And what's going to happen sometimes in grade 12 is this would be a non-calculator part of your test, but you're not recognizing the number yet because there's no square root of 3/4 listed. We have to work at simplifying that, right? So what are our square root rules from before? If you're square rooting a fraction, that's the same as square rooting the top and square rooting the bottom. And if I look at it that way, I'm like, oh, I know the square root of 4. Square root of 4 is 2. And all of a sudden, this looks like a value. So we're looking at sine. So we're looking at y coordinate. Look in your quadrant 1. When is the y coordinate root 3/2? That'll be our reference angle. Pi/3 family. And then according to our cast rule, because of the plus or minus, it's all 4 quadrants. The plus would be 2 quadrants, the minus would be the other 2 quadrants. So that plus or minus says to write our answer, we have to write every single pi/3 family. Every one down. So if it was pi/6, then it would be 1/2. So when we look at our pi plate and we look at root 3/2, and we're only looking at the y coordinate, that only happens at pi/3. So then we only include the pi/3 family members for that. And the most common kind of question that comes up in grade 11 is factoring a trinomial. So off to the side here, here's grade 11 factoring. You would have had 2x² minus 3x plus 1 equals 0. And just like grade 11, in grade 12, we will factor a lot. And the expectation is that you will go right from here, right to the answer. Okay? Now, some things about factoring that will make it easy for you to get to the answer quickly is understanding that factoring is just the opposite of multiplying. If you had the answer and you were multiplying out, the first one is going to have to be 2x and x because that's the only one that will give me 2x². The last ones, here and here, they're going to have to be 1 and 1 because that's the only possibility for getting 1. Sometimes the question, and this is one of them, give you so few options that it actually becomes really easy. Now, when we have something like this and you're multiplying it all out, you would have learned back in grade 10 that maybe you drew these arrows, right? These ones get multiplied, these ones get multiplied, these ones get multiplied, and these ones get multiplied. Right? You have to multiply all of those out. The ones that I underlined in green will give us the 2x². The ones that are underlined in purple will give me the +1, but I haven't put my plus or minuses in yet because it could either be both positive ones or both negative ones. And it'll make a difference. I know that they're both going to have to be negative ones because I need to get a negative 3x. And my outside and my inside ones, negative 2x, negative x, give me negative 3x. Every single time that you factor, it's my expectation that in your head, you multiply it out and check. Okay? Sometimes a good strategy when you're factoring, if you think you can't get it, is get the first ones to work, get the last ones to work, put random signs in there and check. You will get it wrong if you just guess that way most of the time. Sometimes you'll get lucky. But by getting it wrong and checking, you will give yourself a hint for what you should change, and you'll usually get it right on the next guess or two. In a lot of math classes, if you learn math in English, right, you're coming from French immersion or learn math in a different language, you probably didn't see this. Did your teachers ever talk about all these arrows as FOIL? You ever seen that word before? Some yes, some no. So, it just means you multiply your first ones. You multiply your outside ones, your inside ones, and your last ones. So in English, in grade 10, often they would teach students, hey, FOIL, to help you remember to do all 4 arrows. The first ones, the outside ones, the inside ones, and the last ones. But it becomes really important because your first ones will always give you your first ones. And your last ones, when they're multiplied, will always give you your last one. And that's where you're going to start when you factor. You're going to look at your first ones and your last ones and try to fill in those numbers. And then double check the outside and the inside together will make that one in the middle. So now when we get to trigonometry, I do the same thing. To get 2 sine squared, my only option would be 2 sine theta and sine theta. To get the 1, my only option is 1 and 1. I think about my outside and my inside. They have to combine to give me -3. That's going to tell me both of these need to be negative, because that would give me -2 sine theta, -1 sine theta, which will give me -3 sine theta. Once I put it in, I do a complete check, FOIL it all out, multiply everything, double check that it works to make sure that I'm good. Once I have that, we just changed it from adding and subtracting to multiplying. So that means either this one is 0, and the only way this one would be 0 is if you move, and sine of theta would be 1/2. And the second one could be 0 only if the sine of theta was +1. Is 1/2 on our pie plate for your y coordinate? Yes. What family? Pi over 6. That's your reference angle. So we would have, since sine is positive, quadrant 1 and quadrant 2. Second one, that's an axis family. When is your y coordinate equal to 1? Pi over 2. So in grade 12 for factoring, we usually want to factor directly and quickly. So I'm hoping that you get really good at just writing out the answer for factoring. If you come across something that you cannot factor or you're struggling with, on your formula sheet, I haven't handed them out yet, but we're going to get them soon. On our formula sheet is the quadratic formula. So you tried factoring, things aren't working, you're feeling stuff, you can always go to the quadratic formula and use that as well. Okay, now let's up the level of difficulty just a little bit. In D, we have -3 sine theta minus cos squared theta minus 3 equals 0. The difficulty increased here because what's squared is cos and what is by itself is sine. They're different. And you will not be able to factor if you have different variables or different trig functions. So we have to use one of the big ideas in this unit. One of the big ideas in this unit was sine squared theta plus cos squared theta equals 1. We're going to learn in the next unit that this is something called an identity. And our next unit is called trig identities, so it's all about that. But for right now, this is just one of our big ideas. And with this big idea, can you see that if you wanted to, you could either choose sine squared and get it by itself, or I could choose cos squared and get it by itself, by just rearranging. The reason this is important, right? Right now I can't factor because I have two different trig functions. However, if I take the time, I'm going to rewrite the whole first equation, except I'm going to leave a big blank where the co-squared was. And because co-squared theta is equal to 1 minus sine squared theta as one of our big ideas, instead of writing co-squared theta, I can substitute in 1 minus sine squared theta. What this did is it changed my equation to having two different trig functions just to having one. And if I multiply this out, right, because I'd have to distribute my negative, my sine squared will be positive. I'm going to write that first because it's a quadratic equation. I still would have minus 3 sine theta. And can you see that you have a minus 1 and a minus 3 will give you minus 4. Yes, no problem. Now for factoring this, again, take your first one, the only possibility to get sine squared would be sine theta and sine theta. We have options with 4. It could be 2 and 2 or 1 and 4. So now when you have options, you're going to have to do a little bit of mental math to figure things out. And again, the mental math that you're thinking about is in the end, these two, when they're multiplied together, will have to combine, the outside and the inside, will have to combine to get minus 3. I hope you can see that 2 and 2 will never work. Whether you add or subtract, if I put 2 and 2, even though that makes 4, I will never get 3 with a 2 and a 2. But if I choose 4 and 1, I can get 3 if I subtract. I want to get a minus 3. So I would need to have minus 4 sine theta plus 1 sine theta to give me minus 3 sine theta. Quickly multiply the whole thing out. Does my last ones give me minus 4? Yes, they do. My first ones give me sine squared. Outside and the inside combine to give me minus 3 sine theta. So I double check it. Now I would know that either sine theta is equal to 4 or sine theta is equal to negative 1. Pull out your unit circle. We're looking at sine, so we're looking at y coordinates. Do either of those show up on your unit circle? Yes, one of them does. The minus 1 does. Okay, so minus 1 is the y coordinate right down here. So I can say that theta is equal to 3 pi over 2. The 4 is not a y coordinate on here. So then your brain would say, I need to use my calculator. But this question still would show up on a non-calculator part of your test. Because they're going to ask you to think of something that goes back to your original trig stuff. If you have a good understanding of trig, sine of theta is a right triangle. It's the opposite side over hypotenuse. So if I make this a fraction as 4 over 1, can you draw a triangle where the opposite side is 4 and the hypotenuse is 1? No. Because what do you know about the hypotenuse? It's always the longest side. So the fact that this is a number bigger than 1, the reason we can do this without a calculator is because this answer will be not possible. You're able to say not possible without a calculator. And that's true for sine and cosine if it's bigger than 1. Not for tangent. You can have the opposite side 4 and the adjacent side 1. Tangent, you can draw that in a right triangle. But you can't for sine and cosine. So sometimes you will get these values on non-calculator questions that aren't on your pie plate, but are just not possible. So we can still solve them without a calculator. So just like grade 11 math, you have a quadratic equation. The first thing you have to do always is make one side equal to 0, because if you can factor it, it has to be equal to 0 for that special property to work. Because if I told you I have two numbers in my head and they multiply to equal 1, you'd probably guess 1 and 1, and then I'd go, no, I had 5 and 1/5. Multiplying to 1, infinite amount of possibilities for both numbers. Multiplying to 0, infinite possibilities for one number, but the other number has to be 0. So it's really important when solving a quadratic equation that we make one side equal to 0. Now, when factoring this one's tough to factor because the first one is 6 sine squared, and you have more than one possibility. It could be 6 sine theta and sine theta. It could be 2 sine theta and 3 sine theta. Can you see that there's those two possibilities? Some students like to say, I'm just going to guess one of them and see if it works. And if I can't find anything that works with the first one, then I'll try the other one and see if it works. You could do that. Although sometimes it's actually better. So since 6 has more than one option, I go and I look at my last number. My last number is a 1. There's actually only one option for 1s. 1 times 1. So if I start with that, now I can do mental math, right? My outside and inside have to give me +1. Yes?
Will there be test questions or tests where it could be, for example, 1/4?
No. No, if you're factoring, we'll always do whole numbers. Yeah, that's a good question. Like, he was wondering, you could get 1 by doing 4 times 1/4. But for factoring, it'll always be whole numbers. If it's not whole numbers, then we would go to the quadratic formula. So, now that I have the 1 and the 1, I hope you can see that 6 and 1 never give me 1. But 3 and 2 can give me 1 if I'm subtracting. And I would need my 3 to be positive and my 2 to be negative in order to get a positive 1 sine theta in the middle. So then I didn't have to guess for that first one. Because once I knew that my second one had to be 1 and 1, then I could figure that out. Again, if you are struggling and the factoring is not working for you, you can use the quadratic formula. And I'm going to add a question that meets the quadratic formula after this one so that we can see what that looks like. But to finish this one off, now that it's factored, this one could equal 0 if sine of theta was 1/3. This one could equal 0 if sine of theta was -1/2. Now we go to our unit circle. Are either of those on our unit circle? For your y coordinate. The half is what family? Pi over 6. Cast rule would say sine is negative. There we go. Cast rule. Can't be here and here, so it has to be in quadrants 3 and 4. Seven pi over 6 and 11 pi over 6. But this question would be on a calculator part of your test because 1/3 is never a y coordinate on our unit circle, so this means that the 1/3 part is calculated. So now we would do this the same as we did it in grade 11. What would we say? We would go to our cast rule and say, since it's positive, I know that it's in quadrant 1 or quadrant 2. I can draw a triangle back to my nearest x-axis, and I can label my reference angles. And since sine is opposite over hypotenuse on both those triangles, I can label the opposite side as 1, my hypotenuse as 3. And then I can actually solve for my reference angle, because sine of my reference angle will be positive 1/3. So my reference angle will be sine inverse of 1/3. Go to my calculator, and I get 0.34. Yes.
Other tests will all our answers be.
Not necessarily. Like in all of these questions, the reason we're doing radians is because what are we on? E. If I go back to part before A, the domain was given in radians, then your answers have to be in radians. So, and very typical for exam, to make sure that you can switch back and forth on your calculator. Question 1's degrees, question 2 radians, question 3, let's go back to degrees, just to make sure you're paying attention to the domain. But you will find that a larger portion of them will be in radians, because that's sort of like the new thing. If it's in degrees, it's actually a grade 11 question. So you'll find, unless they're like, we want to check how well you know your grade 11 stuff, then they'll put it in degrees. But we're doing grade 12 stuff, we're assuming you know how to do all of this in degrees. Now we're adding the radians as the one thing that's new. So we find our reference angle, and then in quadrant 1, it would be the same as our reference angle. In quadrant 2, right, in degrees you would do 180 minus your reference angle. In radians, you would do pi minus your reference angle. And this would all be calculated. So you would do all of that with your calculator. Okay, we will add one more that involves tan squared x plus tan x minus 7. I will tell you right away that this cannot be factored. And on your formula sheet, you have the following. You can just add this. This one I'm just adding. So if you have space, I don't know, you probably don't have any space. You can add it into your textbook if you want. If you want a blank page on your textbook where this would be good to write, you can go to page 503. So we have this one, it cannot be factored, so we have to use the quadratic formula. Notice on the formula sheet part, which I wrote in blue, that it has x squared. And in the formula, it's x equals. What do we have? We have tan squared. So when we use this for our formula, we will write tan x equals instead of x equals. Our b value is 1, so it would be negative 1 plus or minus. B squared, 1 times 1 is 1, minus 4. A value would be 1. C value, negative 7, over 2 times A, 2 times 1. This simplifies to negative 1 plus or minus the square root of 29 over 2. So if we had done any of the ones that we factored this way, you could have done this exactly the same. Use your quadratic formula, you're stuck factoring. You can always, not wrong if you go to your quadratic formula, even if it can be factored. What you'll find is if you use the quadratic formula on one that could have been factored, what happens inside the square root will always be a beautiful square root, like square root of 16, square root of 9, square root of 25. If you got a nice number inside the square root, you're like, oh, I could have factored this one. But it's not wrong that I didn't. Okay? This, obviously, square root of 29 isn't a nice square root, so we had to use the quadratic formula. And What the quadratic formula does with that plus or minus, and I'm actually going to split it up into the two, you would have one answer where it's the minus and one answer where it's the plus. So we'll do the minus first and one answer where it's plus. It's good to get good at your calculator. So see if you can type this in correctly. On this side, I got negative 3.192 ... On this side, I got 2.19. The ... there, I'm just saying that I'm going to try not to round until I get a final answer. Sometimes in mathematics, if we round too early, we cause our final answer to be off a few decimal places. So whenever possible, we keep all the decimal places that we can. Both of these are obviously not on our unit circle. Okay? So what we need to do is we have to think here, according to our cast rule, tan is negative in quadrants 2 and quadrants 4. And we can label the reference angle for x on both. If you wanted to label a side, tan is opposite over adjacent, so I could say my opposite is 3.19, my adjacent is 1, because I can make that a fraction over 1. What I need to do is I need to find my reference angle by doing tan inverse, and when we do tan inverse, the reference angle is always based on a triangle of actual length, so the reference angle, you're always doing tan inverse, sine inverse, cos inverse of a positive value. And if I do that here, I get a reference angle of 1.27. In quadrant 2, I would do pi minus my reference angle. I would get 1.87. In quadrant 4, I would get 5.02. And that is the only time that I rounded. I used all the decimal places until my very final answer. Same thing here on this side. We would do the same thing to find our reference angle. .14, tan is positive in quadrant 1 and in quadrant 3. And those would be our final answers. So, I have a worksheet for you. I want you to get started on it at home. There are some calculated questions and non-calculated questions. I'm going to give you the first 15 minutes of class tomorrow to ask specific questions. So I'd like you to for sure have questions 1 to 4 done on the first side and 9 and or 11 and 12 on the second side.